Hey guys, today we are talking about applications of systems of equations. So yesterday we learned about solving them using substitution. Today we're going to talk about a little bit more in depth about those equations themselves, but also how we can use these equations to solve real world problems. So first and foremost, yesterday we found that a solution to a linear system of equations is a point at which those intersect. And so whenever we just have those two lines intersect, which is most of them, whenever we have them intersect, that is when we have exactly one solution. So a system of linear equations might have one solution. It might also have infinitely many solutions. So right here it looks like we only have one line graphed, but what if we had another line that was the exact same and we were asking what are the solutions for both of these? Well, if you have two lines stacked on top of each other, that's what we call an infinitely many solutions. Might have one solution, might have infinitely many solutions, or if we have two lines that are parallel, they never cross, so we never get an intersection there. We never get a solution. So the other way that it could be is we could have no solution. Okay? So we're just going to investigate a little bit today what no solution, infinitely many solutions look like. So let's take a look here first at number 1. And let's solve this system. Remember, to solve a system of equations, I like to write one out beside each other. So I'm going to write one out over here, one over here. So I'm going to write over here y equals 1 over 4x minus 1. I'm going to write over here negative x plus 4y equals negative 4. So, first step is we solve for one of my y values, right? Or one of my x's, we solve for one of my variables. And my y here is already solved for. It's already by itself. So I can take this value for y and plug it in for y over here, okay? So let me rewrite this equation. We're going to rewrite it as negative x plus 4 times, remember when we plug this in, make sure that you put it in parentheses so we don't forget to distribute. So I'm going to go 4 times 1/4 x minus 1 equals negative 4. So by doing this, I have created an equation with only one x in it. So let's see if it works out. So let's distribute 4 times 1/4 x. Come on, catch. There we go. 4 times 1/4 x, 4 times negative 1. 4 times 1/4 x is just x. 1x, because 4 times a fourth cancels out that fraction. And so we're just left with 1x. 4 times negative 1 is negative 4. So I have a negative x plus x minus 4 equals negative 4. Okay, so now let's combine like terms. Negative x and positive x are like terms. Negative x plus x is 0 x's. So those two are just going to cancel out. So I'm just going to be left with negative 4 equals negative 4. Listen, guys, if you ever get into a point where an x, there is no x or variable left in my equation, it's probably going to be either no solution or infinitely many solutions. If we get to this point here, where it's just the true statement, my x's are canceled out, we're not looking for what x is anymore, and it's just a true statement where it's negative 4 equals negative 4, this is an example of infinitely many solutions. Okay? This is an example of infinitely many solutions. These two lines are the same line. They are stacked on top of each other. Okay? And we know that because whenever we go to solve it, my x's cancel out, and I'm left with just two answers that are true. Now, if this wasn't true, if it was like 0 equals negative 4 or whatever, if it isn't true, then it is no solution. But since this one is true, it's infinitely many. Let's take a look here at number 2. So number 2, we're going to start off by rewriting my equations beside each other. So I'm going to go y minus 2x equals -1 over here, and then I'm going to write -2x plus y equals 2 over here. So, first step, I want to solve for one of my y values and substitute it into the other side. So let's solve for this y value. Let's add 2x to both sides. And let's get y equals 2x minus 1. Okay, let's take this value for y, and let's plug it for y into my other equation. So I'm going to take this value of 2x minus 1, and I'm going to plug it in for y over here. I'm going to get -2x plus, and you don't have to put really parentheses on this one because we're just adding it. There's no number to distribute, no negative to distribute. So we're just going to go plus 2x minus 1 equals 2. Okay, so there we are. Now, nothing to distribute, so let's combine like terms. -2x and positive 2x are like terms. Oh, but -2x plus 2x is 0. So once again, I've canceled out my x's. Once we cancel out my x's, we're just left with our whole numbers. So that leaves me with -1 equals 2. Hold on. Does -1 equal 2? No. Can it equal 2? No. So if we cancel out our variable and we get to this spot where it's not true, this is an example of no solution. Okay? That's an example of no solution. Okay, so let's move on. And we've talked about infinitely many solutions, no solutions. Well, now let's get into really the applications. So we're going to also be learning how to write out equations that we can solve from word problems. Let's take a look here at number 3. Number 3, at Manny's Taco Shop, you can get an order of chips and 2 tacos for $9.25. I'm going to go ahead and write that out. An order of chips and 2 tacos for $9.25. So I'm going to use C to represent chips, of course, and I'm going to use T to represent tacos. So I can write out this first portion. 1 order of chips, so 1C, plus 2 order of tacos, so 2T, equals $9.25. Okay, that doesn't really help me decide how much tacos and chips cost, but if I had another frame of reference, we could figure this out. Let's see. The cost of 2 orders of chips and 5 tacos is $21.75. So 2 orders of chips and 5 tacos is $21.75. We can write that out too. 2 orders of chips and 5 tacos is $21.75. Hey, we have created 2 equations with the same variable. Okay, so we can use these 2 to solve. So here's what I'm going to do. I'm going to take this one on the left, and we're going to solve it for a variable. We're going to substitute in for that variable to the right. All right, let me draw this line here to keep us all separate. And we're going to start off by minusing 2t, minusing 2t. It's going to give me c equals -2t plus $9.25. Okay, so now I have that value for c that I can substitute for c over here. We can take this value for c and plug it in for c in my other equation. Okay, so that's going to allow me to rewrite this as 2 times -2t plus $9.25. Don't forget to put your parentheses around it so we don't forget to distribute. Okay, plus 5t equals $21.75. And now we're gonna solve, and we're gonna figure out how much does 1 taco cost. So we're first going to distribute 2 times -2t, 2 times $9.25. We're going to get -4t plus $9.25 times 2 is going to be $18.50. Now let's combine like terms. Negative 4t and 5t are going to combine to make 1t. So I have t plus $18.50 equals $21.75. I will then subtract $18.50 to both sides, and that's going to give me one taco is going to be equal to $3.25. Okay? So now, I know what one taco is. And remember, once I know what this is, we need to find my answer here. What is the cost of an order of chips? So to do that, let's take my value for this taco, plug it in for my t over here, and then we can find what an order of chips costs. So let's see here. An order of chips is going to be equal to -2 tacos, but I know a taco is $3.25, so we'll plug that back in, plus $9.25. So -2 times 325 is going to be a -650. Okay? And then if we go -650 plus $9.25, it's actually going to give me $2.75. So one order of chips is going to be equal to $2.75. Okay? It's kind of expensive for a bag of chips. I hope it comes with really good salsa. All right, it kind of gives you an idea of how we can split up my two equations from my word problem and use them both to solve. All right, we're going to get a little bit more practice with this on number 4 here. So on number 4, it reads, Mark has $4.95 in quarters and dimes. He has 3 times as many dimes as quarters. Write a system of equations that can be used to find Q, the number of quarters, and D, the number of dimes that Mark has. So first and foremost, if he has $4.95 in quarters, let's write out that part. So that means dimes, hate it when it does that, this dang old smartboard. Well, let's try that again. Dimes plus quarters equals, we want a Q, not a G, Q, dimes plus quarters equals $4.95. However, we're also going to include how much he gets for each kind. For each dime, he only gets 10 cents. For each quarter, he gets 25 cents. So in other words, it's 10 cents per dime plus 25 cents per quarter equals $4.95. I hope that makes sense. If you get that. So if he has, next one, if he has 3 times as many dimes as quarters, so he has a lot more dimes than he has quarters. So we actually have to multiply the number of quarters we have by 3 to equal the number of dimes he has. So my other equation is going to be 3 times the number of quarters equals the number of dimes we have. Okay? Now you might read this and be like, that's backwards, Mr. Martin. It says 3 times the number of dimes. Well, yeah, dimes is 3 times as many as quarters. We had to multiply the quarters by 3 to get it up to that. All right, so here's my 2 equations. I already know what dimes is. Dimes is 3Q. So we can take this value for D here and plug it in for D over here and get right into solving. So we're going to have 10 cents times 3 Qs plus 0.25 Q equals $4.95. Okay, 0.10 times 3 Qs is going to be 0.30 Qs plus 0.25 Qs equals $4.95. Okay, so let's add these two together. 0.3 times 0.25 is going to be 0.55 Q equals $4.95. And then to solve, we're going to divide both sides by 0.55. 0.55. It's going to cancel out there. I'm going to grab my calculator and I'm going to do this here. We're going to go $4.95 divided by 0.55. Oops, messed up. Here we go. $4.95 divided by 0.55 equals 9. So how many quarters do we have? We have 9 quarters. Seems kind of fitting. They're very similar in shape. So we're going to plug that back in to find out how many dimes we have, because we have more dimes than we have quarters. So we're going to plug this back in. We're going to go 3 times 9 equals D. And so we're going to have how many dimes? 9 times 3 is 27. So we're going to have 9 quarters and 27 dimes. All right? So hopefully this has been of some help to you to figure out how we can break down these word problems, create the equations out of it. If you have any questions, let me know. And I may be putting in a little helper for you on this problem to help you make these equations. But I have full confidence in you. Last little bit, let's take a look at these last 2 statements. Your friend is solving an equation and her last line of work says 2 equals 2. What does this mean? It means that her equation has infinitely many solutions. What if your friend is solving a different equation and the line of work is 2 equals 1? Well, this one is not true. What does this mean? It means that your friend found an equation that has no solution. Okay? Now, you're going to see a lot more that have solutions other than this. Okay? So make sure that if you see one on this that it has infinitely many and no solution, that you go back, check your work, and make sure that you did it right. Okay? All right, guys. Hope you have a great rest of your day.